Aduh. Okay. Hold up. We live? Sabar. Let me check. Aduh. Let me check. Aduh. Aduh. Okay. Sabar. I think we need to stack some more. My setup is kinda waduh right now. It's hard. Can you see now? I'm gonna give myself 90 minutes. Wait, hold on. MIT allows MIT only gives 20 minutes, but I'm not an MIT student. I'm an noob. Is the live? Is it there? Alright. I'm gonna switch off the PC. Alright. So before I start the 90 minutes, don't worry, I've not seen the questions. This is going to be my setup, just to make sure I'm not cheating. Okay, look around, it's just basically basic books over here. This is just for me to hold my thing. My pencil case is over here. Yeah, I think we're ready. I'm ready to start the integration B. Yeah, I'm gonna allow myself 1 hour instead of 20 minutes, because ain't no way I'm an MIT student, bruh. I can't finish the whole thing in 1 hour. Hopefully this is safe. Yeah, it should be good. Right. So one hour 30 minutes. Not too. So my pencil case are gonna be over here. I'm gonna use the no digit today because they're obviously very sexy. What else do I need? Okay, I think that's it. So, gonna start integrating. Oh, crap. Hold up. Look at this cute file I got. Right, so I guess we should start the timer. I'm gonna move my camera back first so I have space to put the iPad. Now I'm gonna get my pens. I think blue should be good. This one. Now I'm going to start the timer. I'm gonna put my pens away first. Alright, ready? Okay. Hold on. I don't know. I don't really care, honestly. It's late enough. My computer is off over there. So yeah, we should be ready to start. Where's my pen at? Over here, okay. There's another pen actually over here. It's a red pen. Do I have a pencil? Do I really need a pencil? Probably not. Or maybe I do. Maybe, you know, knowing MIT, they like to put graph related questions. Anyway, shall we begin? I'm kind of ready, honestly. It's gonna be really fun. You know what? Screw it. Let's start. What the hell? Why is it? Ah, okay. 3, 2, 1. Integrate. Timer started. I'm gonna put it on the side. Okay, let's go. So we can move this away. Oh, hell nah. Okay, let's do question 1. Right, let's start. So question 1. We have to integrate. Question's gonna be right here. So we have to integrate x plus root x over 1 plus root x. Okay. So what can I see? We can factor out x over on the top. We can factor out root x actually. So we get 1 plus root x. I just switched the orders by the way. Because it'll be x plus root x, so it's the same thing plus root x dx. So this will cancel. So we just get the integral of root x dx, which is just that's half 2 over 3 x power 3 over 2 plus c. First one done. Question 2. Let's see. We have to integrate e power x plus 1 over e power x plus 1 dx. Okay, so this one I can do it in my head already, but I'm just gonna show you. So we got e power x times e over e power x plus 1 dx. And you can just do a u sub, but I'm not gonna do that. So we got that's e. I'm gonna put e log. Log is base e power x plus 1 plus c. You can do a u sub. It's just common knowledge that integral of f prime of x, like the derivative, over fx dx is just ln fx plus c. Okay, I'm just gonna write it down so you guys understand why I did that. Okay, question 3. Integrate the cube root of 3 sine x minus sine 3x dx. Okay, what I noticed first is we probably have to use the sine probably you have to use the sine 3x identity. Actually that works actually. So we get integral of root 3 sine x minus 3 sine x plus 4 sine cube x, if not mistaken. Because if I remember properly, sine 3x is 3 sine x minus 4 cube root of sine x. And then put a negative sign, this will become negative. Negative and negative become positive. So this thing will cancel. So we're just left with the integral of the cube root of 4 sine cube x, which is also the cube root of 4 times the integral of sine x, which is negative cube root of 4 cos x plus c. That should be our final answer. Next question. Oh no, we have a log question now. So we have the integral of 1 to e to the e of log x power log what the sigma x power x and then over x squared. Okay. So I guess I'm just gonna use my log properties here. So I'm gonna bring this over there. So it's gonna be the integral of 1 to e to the e of log x power. I can bring this over here, become x power log x over whole thing over x squared dx. I can probably bring this whole thing down and x term will cancel. So it's gonna get 1 to e to the e. It's gonna be x log x over x squared. So this and this will cancel. So I'm gonna get 1 to e to the e log square x over x. Okay, because that term cancels. So now I can just do an easy u sub. So u equals log x, du is 1 over x, dx is x du. If I put it here, that term cancels. Now I have to find our limits. So u equals log e to the e, which is e. U equals log 1, which is 0. Okay, so I'm just gonna get 0 to e of u squared du. It's gonna be 1 over 3 u cubed e to 0. Plug in e, we're gonna get e cubed over 3, and that should be a final answer because if I plug in 0, it's gonna be 0. Alright, next one. Oh hell now, what the hell is this sigma question? Okay, question 5. An integral of negative pi over 2 to pi over 2 cos 20x sine 25x dx. Okay. You know, immediately I'm gonna tell you the answer is 0. Okay. It is 0. And if you want me to explain why, cosine, this thing, cosine is an even function and sine is odd. So even times odd, so I'm gonna write it down, even times odd will give you odd. And it's a general fact, not a general fact, but a formula, I guess, of negative a to a of odd x dx is 0. Because this is the graph is going to look like something that's some pattern here and some pattern up there on the negative side. Negative side, when it's on the negative side, the integral is symmetrical. It's on the negative side. Below the x-axis, you put a negative below the integral, right? And this one, and the top one, just leave it as it is. And they're symmetrical, so you plus them together, you're gonna get it 0. Alright, next one. So this one is done. Okay, question 6. Okay, this one is more looking. So we got 0 to 2 pi of this long thing. So I'm just gonna copy that. You got sine x, cos x, tan x, cot x, sec x, cosec x. Okay, I'm gonna tell you immediately the answer is gonna be 2 pi. Do you know why? Let me show you. So we got 0 to 2 pi, sine x, cos x, tan x. Okay, what's cot? 1 over tan x times sec x 1 over cos x, cosec 1 over sine x. And we have this at the front too with this method. So this will cancel, this will cancel, this and this will cancel. So we're just gonna get 1 from 0 to 2 pi. Integral of 1, which is just gonna be x. Plug in 2 pi, we're gonna get 2 pi. And plug in 1, we're gonna get plug in 0, we're gonna get 0. So it's just gonna be 2 pi. So question 7. Integrate x log x cos x minus sine x whole thing over x log square x dx. Okay, now when I see a log square and a log on the top, I'm really suspecting a reverse quotient rule. What's the reverse quotient rule? Is it root x? No, it can't be root x. If it's a log square, there's no 1 over x. Hold up. It should be though, right? There's no... What? And I'm actually stuck. This is log square, so square whole thing will be root x log x. Where's an eraser? I don't have an eraser. Oh crap. Okay, wait. What's this? Wait, I'm actually stuck. No, what is the function below? Is it log x? What if I divide everything by x? So let's get... Oh yeah, it does make sense because we get 1 over x there. Sine x is from this. This x term will cancel. Oh yeah, that's perfect actually. Yeah, I think I figured out. So I'm gonna divide everything by x, and you're gonna get the integral of log x cos x minus 1 over x sine x, and then whole thing over a log square x. Okay, and so then from this I'll get, okay, this will be log x times the derivative of cos x minus, oh wait, I'm drawing sine x times the derivative log x, and then the whole thing over log square x. So just in case you don't remember, the derivative reverse product rule, quotient rule over v is v u prime minus u v prime over v square. And just to confirm, v square v u prime v, yeah, okay, and then we got the answer. So the answer is gonna be sine x over log x plus c. Yeah, that should be my answer. Okay, question 8. You have the integral of 1 to 2 of 2 power x minus 1 plus log 2x dx. Alright, so I noticed we have a 2 and a 2 inside because I just split it up. So I'm gonna get 1 to 2. I'm gonna do write it as 2x over 2 because of this, plus log 2 plus log 2x. This one will become 1, so it's just the integral of 1 to 2. 2 power x over 2 plus 1 plus ln x over ln 2. Okay, so this will become that's 2 of it is so because it's 2x over 2 ln x plus x plus x ln x over ln 2 minus x over ln 2. Okay, so to come back in, we're gonna 4 over 2 ln 2 plus 2 plus 2 ln 2 over ln 2 minus 2 over ln 2 minus 2 over 2 ln 2 ln, oh damn, ln 1 is 0. 2 times 0 is 0. We can't divide by 0. Did I do the question correctly? What? ln 1 bro, now I'm actually stuck. Did I make a mistake? Actually, did I make a mistake? Bro, surely. Oh, wait, it should be 2. So yeah, okay, never mind. So that will become minus 1 minus ln 1 over ln 2. Will be plus 1 over ln 2. This is 0. So I'm gonna write everything in terms of ln 2 as the denominator. So 2 over ln 2 plus 2 ln 2 over ln 2 plus 2 ln 2 over ln 2 minus 2 over ln 2. That will cancel. Minus 1 over ln 2 minus ln 2 over ln 2 minus plus 1 over ln 2. So observing, again, this will cancel. This will cancel. So it's just going to be 2 plus 2, 4, minus 1 is 3. So we're going to get 3 ln 2 over ln 2. We can cancel this, so the answer is just 3. Wado! Question 9. Okay. Question 9 looks more... Okay, question 9 is actually easy. Okay. So we use sub the inside. So I'm going to get u equals 1 minus x power 2025. du is negative 2025 x power 2024. U equals 1 minus, we do the limit. So 1 power of that is 1 power 2025, 0. equals 1 minus 0 power 2025, which is this 1. So got a negative, so it should be in the negative, but since since the limits are switched, we can switch it. We can get rid of the negative, so we're gonna get the integral of 0 to 1. So power 2024 will cancel. I'm gonna put 1 over 2025 first. Power 2024 will cancel, that'll be u power 2025. So is this gonna be 1 over 2025 times, okay, u power 2025 is just going to be 1 over 2025 times, so it's going to be 1 over 2026, u power 2026, 1 0. We put 0 here, we're going to get 0. We put 1, we're going to get 1. So it's just going to be 1 over 2026, which is going to be 1 over 2025 times 2026. And I have no idea what the value is because MIT don't allow calculators. Next one, so we're done with this page. Question, what question was that? Now we do to question 10. Question 10 looks a bit wado, but still doable. So we got x power x minus half, x minus 1 dx. I don't know what's the shortcut, but I don't care. I'm going to expand everything. So we're going to get the integral of 0 to 10 of x times x squared minus x minus half minus 3 over 2 plus half. Then we get 0 to 10. X cubed minus 3 over 2x squared plus half x dx. We're going to get 1 over 4 power x power 4 minus 3 over 2. Okay, times 1 over 2, 1 over 2. We're going to get half x cubed plus 1 over 4x squared. 0 to 10. So it's going to be 10 power 4 is going to be 100 squared, which is 10,000 over 4, which is 2,000 something. 10 cubed, 100 over 2 plus 100, that's 100. So that's 1,000 over 2 plus 100 over 4. This is going to be 2,500 minus this is 500. This is 25. So it's just going to be 2,025. That's our final answer. That's number 2. Next one. Question 11. Oh, hell nah. Floor function. Also, maybe we didn't get a floor function question. Well, I'm screwed. Okay, what can I do for floor? Okay, what can I remember? So question 11, we have the integral 0 to 20 of floor function x over 2, and then the whole thing is a ceiling function. Wado! Okay. So, one thing I can say about this is when we have a ceiling function of x, we can, this is k plus 1. When this is specific, k is less than fx and fx is less or equal to k plus 1. Okay? And we have a floor function of x, it just equals to k. When k is less or equal to fx and fx is less than k plus 1. Okay? So we're gonna get the floor function, ceiling function of 0 over 2 plus 1 over 2 plus 2 over 2, and it goes on forever. Not forever, but until the last few terms, which is 18 plus 2, 19, 2. Because we have 20 terms here, right? Goes up to 20. So this would just be 0 plus 1 plus 1 plus 2 plus 2 plus blah 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 under 9 plus 9 plus 10. Okay, 0 doesn't matter. 10 is a separate thing, but it doesn't repeat twice. Everything repeats twice, so we have to do 2 times whatever number. Okay, so another formula. Where the hell's the blue blah blah? Screw it. So another formula is when the series to n as k equals 1 of k is just half n plus 1. Okay, it's a formula. So we have k, which is just this from 1, which is true. N is going to be 9. So half times 9. 9 plus 1 is 10. And then we have to plus the 10 because 10 is a separate function. So this will cancel. I mean, not really. I mean, this is just 1. 9 times 10 is 10. 90. 90 plus 10 is 100. So that's going to be our final answer. What do? Okay, next one. Question what? Question 12. So we have the integral. Oh, hell no. What is this? 3 over 1. X 4 over 2. X. We're gonna use this 5 over 3 x 6 over 4 dot dot dot, and I have to draw the square roots. What the sigma? Not square roots, but roots. Okay. Well, this is one door, but it's okay. Alright, so I'm gonna rewrite this as x, the integral of x, 3 over 1. Oh, sorry, 1 over 3. You have to take the reciprocal. Times x 1 over 3 times, because this square root, the second one is inside the first one, so you have to times 1 over 3. Take the reciprocal, it will be 2 over 4 times x 5 over 3, so 1 over 3 times 2 over 4, because this one is inside this square root, which is the square root, not square root but root, times 3 over 5, and then times x 1 over 3 times 2 over 4 times 3 over 5 times 4 over 6, and it goes on forever to infinity. Alright, so this is going to be x 1 over 3 plus 1 over 3 times 2 over 4 plus 1 over 3 times 2 over 4 plus 3 over 5, and it goes on. Now I'm actually curious what to do. Obviously this is a series. 1 over 3 plus 1 over 3 2 plus 2. And what if I take infinite series of I'm actually stuck. 1 over 3 plus. How many questions do we have left? Where's the... over here. Oh, hell no. Okay. Alright. 1 over 3 plus, if I take 2 over 3, wait, sorry, this is times 1 over 3. How about... Okay, I think this will work. 1 over 3 plus 2, factor out 2, you get 1 over 3 plus, this will be 1 over 4 plus 1 over 2. So that's going to be 2 over 3. Two. Sorry, 1 over 3 times 1 over 4 plus 1 over 4 times 1 over 5. Right. Plus 1 over 5 times 1 over 6, and it goes on forever. Put the 2 here. Yeah, the 3 will cancel. Okay. So this will work. Half 1 over 3 times 1 over 4 plus 1 over 4 times 1 over 5 plus 1 over 5 times 1 over 6. That's going forever. We can rewrite this as the infinite series of 3 over 1 over n plus 1. Now we just have to compute this telescoping. So 1 over n plus 1, it's a over n plus b over n plus 1. There's gonna be, so a would be, plug in 0 to that, we get 1. B is plug in -1, we get -1. So we're gonna have the infinite series n equals 3 to infinity of 1 over n minus 1 over n plus 1. Difference is by 1, so we plug in 1, so we get 1 over 3 only. Right? Yeah. So this series will be converts to 1 over 3. So we're gonna have x 1 over 3 plus 2 1 over 3. So it's gonna be x 1 over 3 plus 2 over 3, which is just x dx, and this is gonna be 1 over 2x squared plus c. Damn, bro! That was actually really difficult. Alright. Question 13. Question 13 is doable. I think we can do question 13, no problem. Okay, so 13, I think just a quick use sub should work here. E power 2x, x squared plus x, over x e power x power 4 plus 1. Is this a reverse product rule? Or, wait. Take the derivative of this, I'm gonna get x e power x plus x. But this is a 2x, wait. E x squared e2x. 2x e power x plus 2x. Oh, okay, that actually works. So, I'm gonna just rewrite this as x squared e power 2x plus x e power 2x whole thing over x squared e power 2x and then square and then plus 1. So I'm gonna take u equals to that. So u equals x squared e power 2x. So du would be, so differentiate is gonna, so it's gonna be 2 e power 2x plus, then you differentiate, it's gonna get 2x e power 2x dx. So it's gonna be du would be 2x squared plus x squared e power 2x plus x e power 2x dx, and that will cancel. So it's gonna be half 1 over u squared plus 1, which is just half tan inverse of u plus c. U is this, so it's gonna be half tan inverse or arctan u is just, so that's going to be x squared e power 2x plus c. Should be the answer. So question, what question? 14. So question 14, we have the integral of sec power 4x minus tan to the 4th power x. Right, so how can we solve this integral? 6 squared x plus tan squared x, 6 squared x minus tan squared x, that's not work out. Oh, so 1 over cos, oh, they both are on. Okay, I'm just gonna rewrite this because we can, of 1 over cos squared x minus, this is, sorry, cos power 4x, 1 over cos power 4x minus, okay, this is gonna be sine power 4x cos power 4x, and they have the same base, the same denominator. 1 minus sine power 4x is going to be 1 plus sine square x, 1 minus sine square x, whole thing over cos power 4x dx. 1 minus sine square x is just cos square x and cos square x, so we can just cancel them out. This will cancel. It's going to be 1 plus sine square x over cos square x dx. So this is going to be the integral. This is going to be 6 square x. This is going to be 10 square x. But since we have a 6 square, I'm going to write this as 6 square x minus 1. Because sine square x over cos square x is just 10 square x. 10 square x is also the same thing as 6 square x minus 1. So we're going to get into the integral of 2 6 square x minus 1, which is going to be 2 10 x minus x plus c. Oh. Next one, question 15. So question 15, we have the integral of 0 to 1 square root x 1 minus x. Alright, I know this is not going to be the best method to solve this integral, but this is how I'm comfortable with it because I have an idea how to solve this integral. It's going to be what though? I agree, but it is what it is. My balls are itchy. What do? Ooh. Okay, anyways. Okay, so we're going to do it on the side. X1 minus x is x minus x squared, which is minus x squared minus x. Now we complete the square. Waduh! So complete the square, we're going to get minus x squared minus x plus minus 1 over 2 square minus 1 over 2 square. So this is going to be minus x minus 1 over 2 square. That's going to be in minus 1 over 2 square is plus 1 over 4. I'm going to rewrite this around. I'm going to put the 1 over 4 in front. So we're going to get 0 to 1 of the integral 1 over 4 minus x minus half square. Like that. Alright, so that's going to be how it is. Now, I'm going to use up this so I can get rid of some terms. I mean, I can make it easier for me. So I'm going to do u equals x minus half. Du is dx. And let's put our limit. So u1 minus half is half. 0 minus half is negative half. So we're going to get negative half to half of 1 over 4 minus u squared. And if you draw the graph of this, it's going to look like this. This is going to be negative half, going to be a half, and this whole thing will be y equals root 1 over 4 minus u squared, like that. So minus half to half, we have to cover this whole area, which is going to be half of a full circle, which is semicircle, which is a whatever. Half times, okay, area of full circle is pi r squared. So it's going to be half pi r squared. So what's our radius is going to be half. So half square, which is, so half square is going to be 1 over 4. 1 over 4 times 1 over 2 is going to be 1 over 8. times pi will be pi over 8. That's going to be our final answer. Question 16. Question 16, we have the integral. Okay, this actually looks kind of wado. Sin 4x cos x cos 2x sin x. Okay, this actually looks kind of wado, but no problem. Okay. Sin 4x. I write it on the side lah. Sin 4x is the same thing as sin 2x. Right. Sin 2x is going to be 2 sin x cos x. So, but this is sin 2x. We have 2x. So it's going to be 2 sin 2x cos 2x cos x from the side there, cos 2x sorry, sin x dx. Cos 2x will cancel very sexily. Okay, 2 sin x. Okay, that's all we can cancel. So we're gonna get 2 from this 2 sin x cos x over sin x. Again, this will cancel. So we're gonna get 4 and integrate cos x. So it's gonna be 2 1 plus cos 2x dx, because if you remember, cos square x equals half 1 plus cos 2x, and half we put at the front. 4 times half is 2. Okay, then we're gonna have to integrate that only. So we're gonna get 2 x plus half sine 2x. So it's gonna be 2x plus, okay, 2 times half is just 1, so it's gonna be sine 2x plus c. That's gonna be our final answer for question 16. Okay, question 17. We have the integral of sine x, oh no, hyperbolic, sinh x dx. Okay, shall we do IBP with this one? Yes, IBP, of course. So sin x cos x sin x sin x cos x sin x cos x minus sin x. Screw it, let's just differentiate sinh x. So we're gonna get cos x and then sinh x again. Integrate sign, we're gonna get minus cos x. Yeah, and then from this we're gonna get minus sin x. Okay, so we're gonna get I'm gonna label this i's because I know that this is gonna be the same. So we got I'm gonna do this one first because negative of negative is gonna be plus. This is gonna be negative. So I'm gonna put there equals sin x sinh x and then minus cos x sinh. What the hell am I doing? So I is gonna be sin x cos x minus cos x sinh x. Okay, then minus the integral sin x sinh x dx. This is I. So I'm gonna bring I to the other side. We're gonna get 2i equals sin x cos x minus cos x sinh x. So I, which is just this thing, is going to be half sin x cos x minus cos x sinh x plus c. Woo! Alright, question 18. We have to... Well, I'm done with this one. Question 18. We're almost done there, actually. How much time do we have left? 47 minutes, okay. I think we have time. Woo! Question 18. We have to integrate from 0 to pi over 3. Sin x cos pi over 3 minus x. Is this 0 again? No, there's pi over 3 this time. We cannot just simply say it's even. Hey, wait. This is wait. This whole thing is odd. This is odd. This is even. So whole thing will be odd. But then but our limit is not negative pi over 3 to pi over 3. If it's negative pi over 3, we confirmly already get 0. Very easy. But this time we can't. So okay. Woo! Okay, so we have to use the formula. So we got sin A cos A. So we have to use the formula lah, because I don't know how else to do it. So we got half sin A plus B minus sin A minus B. Sorry, plus sin A minus B. So we have to use this formula. No choice lah. So we got the integral 0 to pi over 3. Wado! I'm gonna put the half outside. So sin A plus B. So x plus this. X will cancel. It's gonna be sin pi over 3. Sin. So A minus B. This minus this. Pi over 3 minus 2x. Hey, wait. This minus 2x minus pi over 3. This is gonna be root 3 over 2. Yeah, root 3 over 2. So we have 0 to pi over 3, root 3 over 4, because we put the half back, dx, plus 0 to pi over 3 sine, okay, this is way more doable, 2x minus pi over 3. Okay, so this one we're gonna get root 3 over 4x pi over 3 0 plus negative half cos 2x minus pi over 3 to 0. So this is going to be root 3 over 4 times root squared pi over 3 minus, so it's going to be minus half cos 0 plus half cos minus pi over 3. This is 1. This is negative half. Hey, wait. This is... wait, so we got pi root 3 over 12 minus half plus... this is 1. Yeah, this is 1. So 1 times half. That will cancel. So it's going to be pi root 3 over 12. There we go. So because cos 0 is... wait. Half cos... pi over 3. Two pi minus pi over 3. Pi over 3 minus plus 0 minus pi over 3 cos pi over 3. And how is cos pi over 3? Pi over 3 60. Should be it. Question 19. Integrate cos x plus cos x plus 2 pi over 3 plus cos x minus 2 pi over 3 square. If they just put like this will be super easy. But the fact they put the square, okay, anyway, we can't do anything about it anyway. Cos x, I'm gonna just use the cos a plus b formula. So it's gonna get cos x plus, okay, so I'm gonna write it on the side. So cos a plus cos b, there's actually a formula for this actually. It's just gonna be 2 cos a plus b over 2 cos a minus b over 2. So I'm gonna put them together. 2 cos, so a plus b, so this plus this, so x plus this, the 2 also will be 2x over 2 cos a minus b, this minus this, x will cancel, 2 pi 4 pi over 3 times over 2 dx. So this is going to be cos x plus 2 cos x. What is cos 2 pi over 3? 2 pi over 3. What is cos 2 pi over 3? Is this correct? This minus this, cos x minus x plus 2 over 3 minus that. Yeah, the thing will plus, so it become 4 pi over 3. And divided by 2, so it become 2 pi over 3. 2 pi over 3. This is cos x. So 2 pi over 3. 2 pi over 3. That's half. Right, so it's going to be 2. Oh wait, that's negative half. Cos x times negative half. Cos 2 pi over 3. How's the graph like that, right? That's 2 pi cos 2 pi. But it feels odd though, because if this is the case, we're gonna get cos x minus cos x, which is just 0 plus c. It feels weird. Cos x, cos. Because we have to square this. 0 squared is just 0. Cos 2 pi over 3. Cos 2 pi over 3. Cos 2 pi over 3. That feels so wrong. Wait, cos 2 pi over 3. There's something wrong about it. I'm sure there's something wrong. I just cannot figure it out. Is cos 2 pi over 3 really negative half? Cos 2 pi 2 over 3 pi. 2 over 3. 2 pi 1 over 10, 20, 2 pi over 3, 120, 60, 120, 120, 20. It is actually. Okay. Well then, I'm just gonna accept it. Question 20, last question actually. Integral of 0 to 1 of the infinite series from k equals to 1 to infinity of negative 1 x, sorry, negative 1k x power 2k. Did I copy that right? Should be. Right, so both terms here have k, so we can just combine them. So we're going to get the integral of 0 to 1 infinite series of k equals 1 to infinity negative 1 times, okay, just to make it clear, I'm just going to write it down for you lah. So x squared and then k. So these two have a common exponent or power, or whatever you call it, of k, so I can just combine them together. So I'm going to get 0 to 1 of k equals 1 to infinity negative x squared k dx. This is going to be a GP. So in a GP, geometric progression, the sum to infinity, because our sum here is infinity, is going to be a over 1 minus r, where a is the first term of the sequence. R is going to be the common ratio. So getting this, we can just find the sum to infinity. So we're going to get 0 to 1. So a first term is going to be minus x squared, because if I plug in 1 into this, we're going to get negative x squared. So we're going to get negative x squared over 1 minus negative x squared. It's going to be plus. So I'm going to put the negative outside. So we got 0 to 1 x squared over 1 plus x squared. Since there's a negative and this is a definite integral, I'm just going to switch out the bound. So it's going to be 1 to 0 x squared over 1 plus x squared. So if you want, you can do long division, but I'm not going to do that because we can just do x squared plus 1 over x squared plus 1. This is nice, but we added the 1. We can't just simply do that, so we have to minus 1. So this is going to be 1 to 0, 1 minus 1 over x squared plus 1. So it's going to be x minus 10 inverse x, and then 1 to 0. So put 0 there, we're going to get 0 minus 10 inverse 0, which is just 0, minus, so put 1 is going to be plus minus 1, and then because negative times negative is going to be positive, plus 10 inverse of 1, which is pi over 4. And then this 1 plus pi over 4. But let's be real, this looks really ugly, so let's put the pi over 4 in the front. That should be my fun answer for this. Okay, now that I still have a bit of time before my time limit ends, I'm going to double check all my answers to make sure there's no stupid mistakes. So let's see. Question 1, let's double check. So let's double check. So this is going to be x plus root x, which is correct. Cancel. Root x, this is correct, I think. This is okay. This one I don't even need to check. This is kind of easy. I'm not. This one should be easy also. I think I got this right. I'm sure I did. I'm quite confident about all my answers actually, because bring the x there, bring this whole thing over there, that will cancel. Log square x over x. Square 1 over 3, e cube over 3. Okay. So I'm gonna get this, should be correct. Log 1 is 0. This is in base e. Next one, cos this is even odd, so it's gonna be 0. So this one is fine. Let's see question 5. Where's question 5 at? Mark the shake man. Oh, question 5 is here, so question 6 should be the next one. So I like this all just once, 2 pi, that's easy. X log as this is easy too. 8. I think I'm gonna submit it as my final answer. So I'm gonna pack up my stuff. Question 9, where's question 10 at? This is 16, that's 20. This one should be 10. So question 10, this should be easy, this should be fine. This one I don't really care, but I think this is correct though. This one is kind of chat, but I did figure out in the end. So, yep. Next one, complete. Question 14. So, we got 14, 15, and then 16 over here. 16, 17. 17, and then about question 20. 19, 20. Alright, so that's gonna be my submission. The MIT integration B. So yeah, where's the cover? Or it's over here. Actually, we do have an extra sheet here. But yeah, that should be it. MIT integration be qualifying exam. I'm just gonna put this over here. I'm gonna cover it. I don't have a stapler currently, but anyways. I'm gonna stop the timer. So we finished it in about 1 hour, which is actually less than an hour to be exact, which is actually quite good. I'm quite proud of that time, especially MIT standard. And this time I managed to complete all the questions. The last time I did the MIT integration B, it was actually, I didn't even finish it. I mean, I did finish it in 1 hour, but I didn't even finish all the questions because the questions are too chat. Anyway, let's check our answers right now. So you can't see the password naughty try to see the password anyways, let's go Google the answers. I was making my thumbnail just now. MIT integration B qualifying exam 2025 exam answers. Let's check. Woo! It's a sexy question just to make sure they match. They do match. Question 1. 2 over 3 x power 3 over 2. Yeah! Second question. E log e power x plus 1. Yeah! I mean, I did put absolute value, but okay, still same thing. Negative cube root of 4 cos x. Yeah! Let's do question 4. Question 0. And no, question 4 is e cubed over 2. Yeah! Then question 5, 0. Yeah! Okay, this question is done. Question 6, 2 pi. Question 6, yep. 2 pi. Yeah! Question 7. Sin x over log x. Sin x over log x. Yeah! Question 8. 3. Yeah! Question 9. 1 over this thing. Yeah! Okay, question 9 is done. Question 10. 2025. 2025. Yeah! Question 11. 100. Yeah! Question 12. X squared over 2. Basically the same thing. Yeah! Half tan inverse x squared to e power 2x. Yeah! Question 14. 2 tan x minus x. Yeah! Question 15. Pi over 8. Yeah! Question 16. 2x plus sine 2x. Yeah! Sin x sin x. Half sin x cos x minus cos x sin x. Half sin x cos x minus cos x sin x. And the whole thing's inside the bracket. Yeah! Question 18. What the sigma? Pi over 4 root 3. What? Oh! Let's check. Pi over 4 root 3. Does it match? If I times 3, 12, root 3 pi over 12. Yeah! I just didn't. This MIT, they just didn't rationalize it. Cos x plus this. What do? 0. Yeah! That's the one I thought it was wrong. And last question. The series got sigma. Pi over 4 minus 1. Yeah! So we got all questions correct. Yeah. So, yeah. Question 21. Doesn't exist. Yeah! Well, just kidding. Anyways, we are done. Gonna need a stapler. So that's the MIT Integration B qualifying exam done. Next time I might do the regular season, maybe next stream. But yeah, need to get my little stapler. We finished this in 1 hour. All correct, very sexy, very demure, very cutesy. I agree. Now I need to get my stapler. John Ibrahim. So let's get my sexy stapler really quick. Then we can staple this up, and this is going to be my new souvenir. But yeah, I'm just going to end the stream right there. Yeah, let's go. Whew. I love MIT. My PC's off over there. I'm gonna put it over here for now. Time to stand up. Let's go. So I actually got this. I want to stick on my room door. Somewhere here maybe. Let's get some stapler. Let's go. So now we're done with the integration. Let's finish it off and staple this thing. Oh, skibidi toilet. Okay, I'm gonna end the stream right now. Bye bye. Thanks for joining. And don't worry, the stream is gonna still be up, so you guys can rewatch the stream anytime you want. That's the MIT Integration B Qualifying Exam 2025. So out of the 40 something questions, out of the 20 questions, we got all correct, but they only gave us 20 minutes. Realistically, in order to do this in 20 minutes, I could probably only get, let's see, maybe like 8-9 questions I can do in 20 minutes. You know, I can't do all of this in 20 minutes. And the back page too. So those who qualify for the MIT Integration B, really impressed by them. And yeah, time to go. Bye bye.